Hi, and welcome back to the C Tutorial Beginner to Pro series. Today we'll be having our first tutorial session, and before we get into the actual coding part of the tutorial session, I felt like last time I didn't explain well enough the program flow and how variables work. So here I've actually written out a little program. Well, I say little, but it's actually quite a lengthy one. It has whole 3 columns of it. You start reading it from the leftmost, then to the middle, and then to the rightmost column. It's a rather lengthy program. That's why I've also have written it here in the online GDB compiler for you. So as you can see, when you run it, it will put the output down here, which we'll look into in a second. And I would like for us to analyze this program, or debug it as some might call, with nothing but a piece of paper. Later on in your programming career, you'll probably be using debug tools, such as, for example, for C specifically, you'd probably use GDB, which is pretty much the de facto standard when you're using GCC to debug your program. Also maybe Valgrind and other such things, but these are for a later section. Now, for now, because it's going to be a bit hard for me to record the piece of paper on which I'll debug, and I think it's going to be rather hard to read because I have very, very poor penmanship. I have also opened it here in Paint, the entire program, as you can see, and we'll be simulating our piece of paper here in this environment. Now, what this program does of interest is quite a few things. Now, if we run it, we see here it says A and B in main and whatever. So, as we remember, our program always starts from main, right? And this is where every C program starts. And the first thing we see is we set B equal to A, and then we define A equal to 8, which is rather weird because what we explained in the first video, this variable here, A, should have to be declared first. Otherwise, C will start complaining. The reason for this is that we all have here a global variable. So this int A, defined here before everything else, is accessible by every other function. And so when you set B equal to A here, it's going to take the value of A here. Now, then we define A equal to 8, which means we initialize a new variable A inside main. So whatever we try to access A from here on out in main, we'll actually be accessing this local variable here. Now, I was quite surprised that this thing worked in C. For example, in Python and some other languages, this thing here would not work. So in reality, you would never write a program like this, but this is a very contrived example of a program that I hope explains well enough how the control flow of a program work and how variables work. So anyways, let's go into our piece of paper and start analyzing. Maybe it first is important to see the output. So here, as you can see in the output, it informs us what the current state of variable is. For example, A and B in main. This means that A is 8 currently and B is 5 currently in the main function. A and B in main, A is 16, B is 5, and the global 8 is 5. We'll see what happens in here. So let's get into debugging our program by hand, and let's see if we can match the exact same output as our online GDB compiler. Now, starting first, although I said we should start a program for void main, first technically C reads everything and instantiates everything. So all of these functions need to be created for your program to work. And this also includes any global variables such as this one. So as I said, a global variable is a variable that is accessible by any function inside of your code. So because we're going to have another A down here, I will write A and then subscript G to denote that this is the value of the global variable. And as soon as our program starts, this variable is set to be equal to 5, right? And then we jump into our main function now, and we create a variable B. So this is the B here. And I'll add the subscript M to denote that this is our B variable inside the main function. And we set it equal to A. Now, we have not set A equal to 8 yet here. So this A will refer to the global variable over here. So this will also become 5 now, because AG is equal to 5. Therefore, B in main will also be equal to 5. And then we create a variable A inside of our main function, so A subscript M, and we set it equal to 8. Wonderful. And then In the next line, we print the values of A and B. So, you know, as in last video, this means substitute this %d with a digit that I will provide to you after I've written the string. Strings are in C written with these double quotations here. So as soon as the string ends, the second parameter of the printf function is going to be this %d here. So we will see, I will write the output here. I won't write the whole thing. So whatever the current value of A, well, because we are referring to A, but we've already have an A inside of A main. Therefore, this will be 8 printed here. And then for B, we'll access this BM here. So 85. So we should see something like this. Then what we do is we set A to be equal to A times 2. Now, for a mathematician, this might be a very confusing thing to see. Something like X is equal to X to the power of 2. And they'll say, oh, the solution for this is 0 or 1 only. In programming, you can set things to be equal to themselves sometimes something else, because what this means is set A equal to the value of A that it's currently before we have made any changes here, multiplied by 2. So what will happen now is AM, because as I said, this is in the main function, we refer not to the global A, but to our local A, or the A in main, will become 8 times 2. So A will now equal 16, right? As I said, my handwriting is a bit illegible, but I hope you can see that this is a 6, so now it becomes 16. No longer is it equal to 8. And then we print whatever. We should now be printing 16, and then because we haven't changed B, it will still be 5. And then we access the get global. So what happens now is our main function stops working, and well, it doesn't stop working, but we jump to here. And what get global does is going to print global A %da. So it will say what is the global variable A currently equal to, which currently is equal to 5. So we should be seeing something 8, 5, 16, 5, 5. I will not write this whole string here because I think it's not necessary to write these strings. Right. And then we create a new variable C, so C in M, because once we reach this bracket here, we return to our main program. So here we make this jump back here, and we're onto this line, which is an empty line. You don't need to write empty lines here, right? As I explained, C, you can write your whole program on one line. We technically return wherever this ends. So the next line, we create a C in the main function, and we set it equal to A. What does this A refer to? Well, it refers to our 16 that we had here from AM. So CM is now currently equal to 16. And then what do? We set B equal to whatever is returned by sum with parameter B. So what this will do is first we'll jump into sum B. Maybe it's good to use another color here. Red seems good enough. So we'll see this jump here to over here. So what sum will do is it will take whatever parameter we have given it, which currently is going to be B, right? It will be called B, but it's currently also equal to B. Do not be confused. We could have as easily put C here. So sum C, and inside of this function, whatever value C was equal to will be equal to B. So technically what happens now is inside here sum, we create a B subscript S, so B inside S, and we set it equal to the value of B as we call it here. So this will be 5. So we have B subscript S accessible here. And then what this function does, it's going to return summing B plus A. What does this A refer to? It refers to the global A again. So the return value red will be 5 plus 5, which is 10. And then as soon as we return, we go back to here, and this value does not exist anymore, right? This BS5 stops existing. And we have now B. Let's get our white again. BM will be equal to whatever has been returned, which was red 10. So B inside of the main function will now be equal to 10. And then we set A to be equal to C. So AM will be equal to CM. Since we had originally set C to be equal to A, there will be no change in the value. So then we were going to print A and B in main. So what we should see is 1610, right? Because AM is 16, BM is 10. We should be seeing 1610. And then the next line is get global, so we should now see whatever the value of the global thing is, so AG, A subscript G technically, 5. So we should be seeing 8, 5, 16, 5, 5, 16 until now. And then what do? We set C to be equal to C minus 1000. So this means that C will now become, if I'm not mistaken, 984, which is 16 minus 1000, right? 16 minus 1000, 984 set that to be stored in C. So you can think of variables as something that store values, and these things can be accessed and these things can be changed with some very, very minor exceptions, but for now we don't need to look into that. And then what do? We go into the increment function. Now let's pick a green color. So we'll make a jump here for the inc function, which is all the way up there. It's already getting confusing, as you can see. What does increment do? It says the value of a to be equal to a plus 1. What does this a refer to? Well, this a here that's inside of our main function is not accessible to the increment function, as we saw last time. So what this refers to is our global a. So what this does is it's going to increment a global with 1. Increment means to add 1. Right, there we go. And then we print. Well, we haven't made any changes to our a and b, so we should be seeing 16 and 10. And then we're going to get global, which is going to return 6 now, because a global is currently equal to 6. And then what do? We set a to be equal to the return value of calling sum with parameter b. Let's get yellow, so we make this jump again all the way up here to sum. Great. And we create a new value. Let's make it yellow again. So we create a bs again. It's going to be equal to b. As I said, we could have just as easily put something else. You don't need to make him match. So bs will be equal to whatever the value of b is currently, which is 10. And the same as last time, we return 10 plus 6. So return value will be now 16. And we reached the end of here. So this value no longer exists, right? I mean, variable, not value. Variable b no longer exists because we return from the function. And where do we return to? We return to over here again. So now what does this do? We set a to be equal to the return value, which was 16. So am becomes 16 again. No change. Unless I'm making a mistake somewhere, we can always check our compiler. Well, it's saying the same thing, so I haven't made any mistakes in my math so far. So what do? Then we print a and b again, so we should be seeing 1610 again. And then we do get global, so we should be seeing 6 again, since we have not made any changes to ag or a subscript g. Now what do? We call dec 3 times. Let's get purple, should be visible. So we find the function dec, we jump to it. What does it do? Well, it does a very similar thing as inc, except it does it with the opposite. So it decreases the global variable a by 1. So a will become 5, right? We go to the next line. Well, again, dec, a will become 4. We return to the next line, which is again dec. So our global variable a should now be equal to 3. And then what do? We set b to be equal to c. So the value of c is currently negative 984. I forgot to add the negative sign there. And this now becomes negative 984. Our b inside the main function is now negative 984. We print. What do we see? Well, no changes to a. It's still 16. It's been 16 for a while. And then b is now negative 984. And then the next line is to get global, which is currently should give us 3. Now what do? Then we set a to be equal to a times 4. So we do 16 times 6 times 4, 16 times 4, which is 64. A nice round number in computer science. And then what do? We set a to be equal to a modulo b. So a will now become the remainder of dividing a by b. So this is the remainder of 64 divided by negative 984, which is 64 as well. Well, I had to verify it just to make sure I'm not making a mistake, because 64 is a lot less than 984. So 64, when you divide it by 984, gives you 0 with remainder of 64. So A does not change its value again, but for the sake of it, let's just say that it has made some sort of change. So as you can see, A is now 64. We call decrease B. We call decrease with parameter B. Let's see what decrease does. Let's find this function. It's over here. What does it do? It takes creates a local variable A. Again, ping. So it will create a D, and it will be set equal to whatever, because we called it with parameter B. B is equal to negative 984. So we have this local value of 984. And then what do? We decrease it by 1. So we set A to be equal to A minus 1 over here, as you can see. Now the reason I created this function is to show you that this A refers to the parameter A, not to our global A. So what this will do is now AD will become equal to negative 985. Right? And then we reach the end of the function, and this variable is destroyed. So technically this line has done nothing. And then we print again. So we do A first, which is now 64. And then B, which is still negative 984 because we have not made any changes to it. And then we get global, which is still 3. Right? Then we set C to be equal to 0 on this line. Right? We've done these two lines, so now we're on this line over here. So we set C to be equal to 0. Let's find our C. Right? This is now, C now becomes equal to 0. Next line, we call function negate B. What does negate B? Negate B actually has a rather interesting operation. Let's take orange for this one. This looks a lot like a circuit now, if you've ever seen one with all the jumper cables in real life. It has the whole rainbow there. Negate over here, I found it. What does it do? It takes creates a local variable B, which is its parameter. So let's create this B n, so B negate subscript, which will now be equal, we called it with value B, so negative 984, right? And then what do? We return A minus sum of B. So what here, this A refers to our global A, so what here we have here is 3, because that's currently the value of AG, minus, and then the return value of sum B. So what does this do? We make another jump here to our sum B, to our sum with parameter B. We create a, let's stick to orange for now. We create a new B, which is going to be our B inside sum. So B subscript S. It is equal to, since we call it with this B, which is our B subscript N, so B here is equal to negative 984. And then we return B plus A, and A in this case refers to our global A. So what we do is we return 983, negative 981. And because we've reached the end here, we've reached this bracket, we've returned, well, we haven't reached the bracket, we've reached the return statement here. This variable B subscript S is destroyed. So we're back into our negate function. We jump back to here. So from here now we go back into negate, or technically to here. And now what happens is we do 3 minus negative 981. So this becomes a plus 3 plus 981. So the return value, let's write it here. The return value of negate with B becomes 984. So I think now it becomes clear what negate does. It takes a variable and returns it with minus in front. So takes the opposite of that variable. So if you put in 3, it will return -3. If you put in -5, it will return 5, right? So we're now returning back to here from all of our jumping between functions. And this return value, we don't do anything with it, right? We did return 984, but it's not stored in anything. So yeah, it's basically not used. Then we go to the next line, and as you can see, this plus 984 is completely ignored, because now A is still equal to 64 and B is still equal to 984. And then we get global, which is still 3. Nice. So we've done this. Now we set C equal to B to 0 again. Well, before we had it equal to 0, but let's set it equal to 0 again. And this time we do the whole jumping again, but this time we store B. We store the return into B. So I'm not going to do this whole jumping thing again. I will straight away tell you that B now becomes plus 984. As we saw it last time, this is the return value of the function. So it's going to be the same again since we've not made any changes. But this time we'll actually store it into B in main. Great. And now we do another print. This one should give us 64 plus 984. And then finally get global 3. We've not made any changes. And when you reach the end of the bracket, our program terminates. Everything is destroyed. Right, so what we should see is 8.5, 16.5, and let's verify that that is indeed the case by checking that the online GDB has indeed said so. So we have 8.5, 16.5, then our global variable is equal to 5. That is indeed correct so far. Then we have A and B 16.10, right? No changes to A, so 5. That was what we had before as well. We call the increment function, so our global A, we are currently over here. We call the increment function, so now no changes to A and B, and global now is 6. Right? We set A to be equal to the sum of B, which turned out to still set it to 16. So we have 16.10 still over here for this line, and then global A still remains 6. Then we decrement 3 times, and we set B equal to C. So we see 16 and negative 984, and for global A we see 3. And then we do the times 4 and the modulo 64. So and then we do the decrease B, but of course, as we said, this makes no changes because we don't store it into anything. So when we print, we get 64 because of this 16 times 4, and because the modulo of something smaller than the thing that should be in here just returns you whatever you had put in the first parameter. Right, so we get 64 and negative 984. Global A is still 3. And then we finally store our negate. Now we are here. We set C equal to be 0. We negate B, but we don't store the return value of negate B, so we still get 64 and negative 984. Here I made a mistake. We don't need to store anything. The issue here is that this changes a local value in decrease, right? Remember, this was the case. Let's find it. This was the case over here, like this pink thing, right? We didn't return anything from it. We didn't make any changes to global variables. Therefore, whatever changes we made inside of it, for now at least, mattered not. Right, and then we see the 64 negative 984 3, and then we set C equal to be 0 again. This time we store the return value of negating B and get 64 plus 984 and global 3, which is exactly what we had inside of Paint. So we were able to debug a program successfully. I hope this clears up how variables work and how the whole control flow, not the control flow yet, just the flow of a program of C works with all of its functions and whatnot. Right, so last time I gave us an exercise, a few programs to make, those being cube, which takes a float of A and prints the cube of the float, a void cube. So let's make that one first. Let's get rid of whatever we had in here. We don't need these anymore. Let's leave just the main and the stdio. Right, let's clear everything. Right, let's make a void cube. which takes a float, right? Takes a float, if I remember correctly. Yeah, float A, and it should print the cube of this. So, right, we're going to print a float. So we do %f, and we do A times A times A. Alternatively, what you can do is set it A to be equal to A times A times A. That is just as valid. Or you could have left it here. Or you shouldn't do both, because now you just get not the cube, but A to the power of 9. So both of these are fine, and let's make sure it works correctly by calling it a few times. Let's say cube of 2 should return 8, a cube of 3 should return 27, a cube of 1.3 should return, I'm not sure, I'm not going to do the math in my head that fast, but it should probably return something correctly. Because we didn't have a new line, things look a bit ugly, so let's add a new line here, and we get 8, 27, and 2.197. Great. So this is your cube function that was in there. The next one that we had to make was sup, so takes int a and int b and returns the result of subtracting b from a. Okay, so we are going to make it here. Int sup takes int a, takes int b. I probably should have explained, doing the cube is the same as multiplying the number 3 times by itself, which is what we do here. We take a multiplied by a multiplied by a, and only then do we store whatever the result of this equation is into a. So subtracting here, it's set to return the value of subtracting a from b, of b from a. So what we do is a minus b, and this should give us the correct implementation. Let's test it out by printing a few things. Since it's a integer, we do %d. Let's do a new line, and let's call it subtract with 5 and 6 should return -1. Let's copy, because I'm too lazy to write this whole thing again, and just change these things. Let's call it with 13 and 2 should return 11, and 1000, well, that's 10,900 should return 9,100, I think, right? Sounds right. Okay, let's see. Yeah, about what we expected. Great. And let's see, say 3, which prints a 3 times, then prints b 3 times, which takes a character and b. Okay, so it's a void, doesn't return anything. Say 3 takes character a, right? It was a character first, then the integer, yeah, character first, then integer, so character a, integer b. It's usually good to give them better names. For now, I'll stick to writing a and b, because our programs don't have any meaning yet. When we get to more complicated programs, we'll put variable names that make more sense. So what we need to do is print a 3 times. Since we're printing a character here, do %c, then we do a. Right, this means print this character. We don't want to print them, as you can see from the next slide. We don't want to print them. How did you change slides? I'm getting a bit confused. So as you can see, we just print them with a spacebar. So it does, for example, with B4, it should do BBB space 444 and only then a new line. Right. So let's see. We can just copy paste at this point. Formatting got a bit weird, so let's remove the spacebar I had copied there. Then we want to print a space, right? Equivalent of this is to put the space here and remove this. This is commenting out something, so this is not used, or just deleting it. So it's the same as what we had originally. And then we print, let's do it %d, 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 and then bbb. This is the same as writing the same thing over and over again as we did the first time. So let's see if we call it, say 3. The example was with character b and then 4. So character b, then 4, and then remove this unnecessary bracket. Then the other example in the slides was point and 75. Just because I'm lazy, I don't want to write this whole thing again. So point or dot or full stop, whatever you want to call it, 75. Let's run it. We were supposed to add a new line here. That's what I forgot. Right, and we see BBB space 444, new line dot 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 space 75 75 75, which is exactly what we wanted to achieve. And these were the programs. I thought of another one that I thought would be a good exercise, which is the mode by 2. The reason I wanted to try it out, as you can see, float mode by 2, is that we should also do mode by 4, which uses this multiplication by 2. So let's do those two. Because they weren't part of the tutorial, that's fine, don't worry. Sorry, of the expected things for the tutorial. First is mode by 2, which takes a float a, and what it should do is should return the value of a times 2. So let's try it out by calling printf mode by 2, float, right? And it's good to add a new line always. And then calling mode by 2 with 7 should return 14, right? And then if we call it with, since we're working with floats, we can work with non-whole numbers. So let's do 19.324. Let's do another one for the sake of it with negative 0.7 to 0.75, just 75. There we go. And let's see if it does everything correctly. So 7 times 2, 14, 19.34, 38.64, 7999. There's a reason why this happens, which I don't want to get into now, but you'll find that float point arithmetic can sometimes be a bit inaccurate. If you've done math, you know these two things are pretty much equivalent. If you were just to truncate, or sorry, round to the third digit after the decimal, it is indeed correct because it should be 648, but we get 647,999. The reasons for that I am not going to get into now because they're, I think, a bit too complex. And then we have multiplying by 2 of negative 0.75, which is negative 1.5. And now I want to do float mode by 4. So what this should do, I want, yes, so you give it a float a, and it should multiply it by 4, but I want to use mode by 2, so as to reuse your old code. So what we'll do is just, we're going to multiply 2 times mode by 2, and calling it with a. So we're going to reuse the same things. We should now see 28, right? 28, 77, it gets even more inaccurate as we keep going up, and negative 3. Float points, a bit inaccurate, that's why I recommended you use doubles, right? A bit higher precision sometimes, but still. Yeah, as you can see, the value changes. One last thing I wanted to mention, so if we take our original program, remember how we had int b equal to a here, if we reverse these two operations, so we first initialize an a to 8 and then we initialize value b to a, we actually will get completely different results from before. As you can see, b and a will now be equal to 8, 8 instead of the old 8, 5, and then we still get, the 16, 8, but things here start to change a bit, and then we get not 64 but 76, and things change a bit. So the order of these two operations mattered, because if we had them like this, we were referring here to the global A, which was 5. And now if we do it like this here, we'll be referring to the local A, which is 8. Just something to clarify. And I think this about does it for the tutorial. I hope this was useful. And the next lesson will deal with control flow programs. So conditional operations, loops, and all these cool things. When you're done with that, you'll be easily able to make, as I said, 95% of all programs out there. Of course, will take you a bit more code, but there's a notion in computer science of Turing complete. Once you know how to do conditionals and loops, you'll be able to use C as a Turing complete language. So hope to see you then, and I hope you enjoyed this video. If you did, if you found it useful, please leave a like and consider subscribing. I appreciate this very much. And